Hi all. In this video, we are presenting a paper titled Rapid Object Detection using a boosted cascade of simple features from Viola and Jones. So this is a famous algorithm for object detection or face detections. So this paper itself claims that they are presenting a machine learning approach for object detections, especially like kind of a face detections which could able to capable of processing images very rapidly and as well as with the high accurate rates or detection rates. So they have three contributions. The first contribution is representing the image as a new format like integral image, and the second one is once that integral image is being represented, it extracts certain features using R-like features, and those features are selectively done from the Adabos. Adabos classifier have two contributions. One is it's selecting the critical features and also to make efficient classifiers. The final contribution is about combining different set of classifier in a cascading stage so that false positive would be minimized. So this set of three contributions have been very nicely explained in this paper. Study of Viola Jones real-time face detector. As it mentions in the original paper, it says that it has three main ideas. One is representing the image in a new format called image integral. From that representation, it tries to extract the features for face detections. So this is where image integral representation is done by this one. It tries to sum up the values from the left and the top values, some of the pixels from the top and the left side of the x, given the xy values. For this is one. For this only the left side is that. So two, one is only two left sides, other three. Similarly here, one is only on the top up here, only one two tops are here, one is here, one left and two left, so that's four. So these are the something some kind of image representations. Once image representation, they are using two types of R like feature. One is for vertical and horizontal, which is been represented in this figure. So using those features and certain summation setup, we could extract for a 20 cross 20 pixel or 19 cross 19 pixels image representation. We can extract almost 34,200 features, and that for extracting those features, this is the equations being applied, which have some additional and subtraction operations by for the nearby operations. So once that is been done, then we put that into any classification algorithm. Here they choose a simple variant of AdaBoost, where it has many weak classifiers, and those mini classifier not only helps to build a very strong classifier, it also helps to extract the important features from this large number of huge sets. So for that, these training images sets can be represented in a matrix format, where these are the rows are number of features and the columns are the number of images. That grouped into 5,000 in number of images there. So the group of 5,000 has been done. So almost like 6 or 7 sets have been given. From that, Adabos classifier chooses which set to be a fit for a particular type of weak classifiers. So once this has been done, the third stage is like kind of a cascading stage, which we have a multiple stages. We'll make a threshold. Every stage has some classifiers. Classifiers threshold is being done set up. There is no false negative. The false negative is minimized at all stages. So that would be, so once the false negative is minimized to all stages, what this algorithm does is it tries to make a classic cascade of things, and each job is to determine. So each we know that a patch an image is given, and we can generate patches of 19 cross 19. That is a sub window given to that, and sub window is given to the first stage. It tries to detect whether it is a false or negative, and if it is the detect negative, there is no face, then that will be definitely discarded, because we have set up a threshold that will not be false negative. The second stage will be given, and again that it will try to filter out whether it is false positive or false, whether it is we have a face or not face. If it is a face, then it will go to the next stage. If it's not a face, it will be that sample will be rejected. So at each stage, we will make sure that the threshold is high enough so that there will not be false negative. So that will be reached to a stage until there won't be any kind of false positive or false negative. So one here another important thing is during the training only the samples which have been rejected by which have been passed through by these stages will be taken to the training for these stages, and this will so that the hierarchical of increasing the difficulties during the training will be increased as the stages are increased. So these are the main important contributions from the Lyra Jones work, like a hierarchical way of iterative or hierarchical deep learning what we are doing from some sort of things. It has a cascading process such a way that we don't get any false positive at all and false negative at all. It also tries to avoid the overfitting, so it can be generalized for any data sets for a given number of training sets. So three contributions again: the integral representation, extracting Haar-like features, then extracting the important Haar-like features. Once that is been done, we are also parallelly building stages of classifiers based on ADA boost, so that false. So that when non-face is done, then that stage will be stopped, but when the face is detected, then the stages will be increases. So this will help in certain way of efficiency, because when an image is detected, when an image is taken in a only a few only a particular region will have a face, and other most of the 75 to 80% region won't have any face. So this stages reaching that last stages only for a few particular regions. So remaining 80 percentage of those window patches will be rejected at the earlier stages. So it will be more efficient at the real-time computations. So these are the main key attributes of these algorithms. Hopefully, we'll see about different algorithms in the next video. Thank you.